When engineers attempt to wire together an array of distinct AI tools on a single machine, the entire system often buckles under its own complexity. Setting up a local environment now requires manually maintaining configurations across a dozen separate clients, from heavy GUI editors like Cursor to terminal-based assistants like Aider and Quen CLI. Because these tools do not speak to one another, they hit disparate API limits, they misroute requests and strip away vital context, resulting in constant deployment failures. The OmniRoute deployment protocol exists to solve this by acting as a unified routing middleware system, a centralized traffic controller for the entire AI toolchain. But the source document outlining this deployment is not written for a human engineer to read and manually execute. It is a strict, declarative protocol engineered specifically to constrain and direct an autonomous AI DevOps agent. By defining a strict expert persona in the very first line, the prompt establishes the operational logic and the exact technical standard the agent must adhere to throughout the entire deployment process. The agent is given a comprehensive mandate. It must autonomously install, configure, verify, and optimize the OmniRoute system, pulling its instructions strictly from the official GitHub repository source of truth. By decoding the exact configuration requirements demanded in this prompt, we can map the internal architecture of this fault-tolerant gateway. Analyzing these instructions exposes the structural anatomy of the OmniRoute middleware, while demonstrating how modern autonomous systems execute complex local deployments. The foundational parameters of the system are established immediately in Rules 1 through 4 of the protocol. Rule 2 explicitly demands that the agent detect a host operating system automatically, stripping away any need for human input. Rule 3 then forces dynamic, cross-platform dependency resolution, instructing the agent to pull specific requirements based on that initial OS detection. Visualize this dynamic filtering generating a stable, uniform architecture, regardless of the host machine. Docker is listed as an optional dependency. This proves OmniRoute structurally supports execution across two paradigms: isolated containerized microservices, or natively on a bare metal node. Forcing the deployment agent to dynamically adapt to the local environment and resolve its own dependencies eliminates the classic failure state of local engineering. It ensures true infrastructure portability. Requirement 5 dictates the strict configuration of the core routing engine. The primary function of this engine is architectural decoupling. It removes model routing logic entirely from the individual client applications. Incoming requests flow from clients through the central OmniRoute gateway and split out to external API providers. Before the routing switch, requests hit a context compression layer. By reducing token payloads here, the system optimizes costs globally before hitting external APIs. The prompt also introduces a critical requirement for auto fallback configuration. If a primary external API provider goes down or returns a rate limit error, the router instantly redirects that specific payload to a secondary pre-configured provider. Because this redirection occurs entirely within the middleware layer, the failure remains invisible to the client tool making the request. The autonomous agent is tasked with building and testing these failsafes without human guidance. Setting up a multi-tiered fallback strategy guarantees that end users maintain high availability even during massive cascading API outages. Shifting the routing logic, payload compression, and fallback protocols into the middleware isolates the user's primary coding environment from the inherent volatility of external LLM providers. Requirement 6 shifts the agent's focus to a massive integration matrix. The agent integrates 14 distinct clients, handling connections for Claude Code, Roo, Goose, OpenClaw, and numerous others simultaneously. Maintaining state, routing preferences, and continuous context across heavy GUI editors and lightweight CLI-based tools creates immense technical friction when attempted manually. To manage this, Rule 5 explicitly requires the configuration of two specific standards: the Model Context Protocol, or MCP, and agent-to-agent communication. Disparate clients connect to protocol ports on the OmniRoute hub. MCP allows the middleware to translate proprietary requests into a standardized context format. Simultaneously, A-to-A configuration enables autonomous tools to bypass standard interfaces and communicate with the routing backend natively. Forcing a single deployment agent to map and configure this entire matrix ensures that all 14 distinct endpoints are synchronized to the same logic rules. With a unified backend in place, developers can swap out their front-end tools at will, retaining specific routing rules, fallback chains, and compression preferences regardless of the client used. By mandating MCP and A2A connectivity alongside standard API endpoints, the protocol transforms OmniRoute into a universal bridge capable of unifying a fragmented tool ecosystem. The rigorous verification mandates in Rules 7 and 8 detail how the agent must test and maintain this complex system. Traditional continuous integration pipelines operate on a linear expectation. If a script encounters a failure, it halts execution and outputs an error log for engineers. This deployment protocol abandons the linear script entirely, operating instead as a continuous, self-monitoring state enforcement loop. The language in Rule 8 is uncompromising. If an error occurs, the agent must diagnose it, explain why, and fix it automatically. If a localized streaming failure occurs on one of the tool integrations, the continuous scanning orbit detects the broken connection immediately. Without waiting for human intervention, the agent executes a closed-loop diagnostic, rewiring the configuration seamlessly. The prompt adds a critical operational constraint, ordering the agent to continue without restarting unless necessary, ensuring that system uptime is preserved while repairs occur in the background. Rule 8 defines the operational core of modern agentic DevOps. Deployment transitions from a fragile, one-time event into a self-healing process that actively defends its own runtime state. Under Requirement 9, the agent finalizes its mandate, producing the installation logs, the recorded configuration states, and the environment variables for the user to review. The resulting architecture operates as a high-bandwidth gateway, processing massive throughput while enforcing uniform routing logic across every connected tool. OmniRoute operates as a highly intelligent, localized infrastructure layer, establishing a defensive buffer between the developer's machine and the chaos of the broader internet. Centralizing context management, model routing, and multi-protocol translation into a single controllable node eliminates the vast redundancies of maintaining separate client environments. Delegating the execution of this massive integration matrix to an autonomous agent bypasses the human bottleneck, stripping out the manual configuration drift that plagues local engineering. The strict instructions mapping the OmniRoute deployment protocol demonstrate that the future of infrastructure engineering relies on systems that are strictly declarative, inherently self-healing, and universally integrated.